Right. Explicit is not explained here. Explicit curve is something like this one. You are already know well. This one is y equal x, right? And then this is something like y equal x squared, right? And then we moved this one is in this way, then y equal x plus 5. And then this one we call this explicit representation of curve. And then you know that x square y square equal r square something. The circle, right? This is also explicit. Parametric, I'll show you later. So there is no xy. So x equal functional parameter p. So it's something like what? X p square plus 3p plus 2 something. This is a parameter. Y also represented by another function of p, and also g also is represented by parametric function. We call this is parametric function. Y is good, but this one is used for the computer system, nerves. So we will see why and what is this. So how am I explain? This is this is still it's a cubic function. Cubic function. Something like this one. Cubic. It can be used as ax b dx here cx plus b, something like that. It's covered. And this one we call this cube. So much explain. And then it's important, defined by endpoint and also end tangent vector. Four parameters. 2 position, end position, and 2 tangent vectors. Let's show you the video.
밥을 먹는데 돈을 내야 되겠죠. 계산할게요. 어떻게 해야 할까요? 계산을 직역하면
No sound. Right? So 2 endpoint and 2 tangent vector. That is a requirement to define or to generate a Hermite curve. We call that cubic Hermite. Right? But as a designer, you want to design some curve, right? Right. We will have a more different curves. And Bezier is a person name who was an engineer at Renault. Renault is a famous French automotive company in during 1960s. He developed this. Oh, something is moving. Right. But this one is also parametric. But this one is good that you just define 4 points. 4 points. We call this as a rating function. Rating point? No, there's different. I cannot remember this. By defining this 4 point, then the system can generate this vertical line curve. Good. So you can imagine that what can be the output result of the shape of the curve by defining the bounding box or something. Those 4 points. And they by blending. Combine those two numbers and those two numbers and two numbers and by two numbers, and it's calculated in this. If you have a 6 point or 5 point, here's 5 point, the curve goes in this. So we call this only 3 point, 4 point, 5 point. And then this one is 2 points. So this is a linear, quadratic, cubic, and quadratic. And then the order is coming higher, right? Linear, quadratic, and cubic. Bezier, again, same one. Good. They show how the curve is generated by combining them together, or blending. We call blending. Yeah, interesting. So designer need to give only the point. We will see from there should be a name coming in this video.
Hello everyone. Bezier curves are used to draw smooth curves that can be scaled indefinitely. I will be doing a lot of tutorials where I will be using them, so I thought maybe I should make a video explaining them, so you can have an idea of what it is all about. A Bezier curve is defined by a set of control points. For example, to draw a line segment we need 2 points. In this case, P0 and P1. To get any point in this segment, we use a linear Bezier curve function, which is equivalent to a linear interpolation, with t varies from 0 to 1. This function simply means that the influence of each point depends on t. For t equal to 0, we will get P0. For t equal to 1, we will get P1. And for each value between 0 and 1, we will get a point along the line segment linking P0 and P1. Here is a visualization of how it works. Great, that was pretty simple. Now, what about drawing a curve? In this case, we need 3 points and use a quadratic Bezier curve. First, we need to do another linear interpolation between P1 and P2, and then interpolate between L0 and L1. This will give us Q0. If we trace the path of Q0, it will show a curve going from the first point to the last point. The first and the last control points are always the end points of the curve. This function can also be rewritten into this form. This is what is known as a quadratic Bezier curve. For a cubic Bezier curve, we need to add another control point, P3. We do a linear interpolation between P2 and P3. We call it L2. We do another interpolation between L1 and L2. And finally, we interpolate between Q0 and Q1. If we trace C0's path, it will look like this. We can rewrite the function into this form, and this is what is known as a cubic Bezier curve. So, after all, quadratic Bezier curve is just an interpolation between two linear interpolations, and the cubic Bezier curve is an interpolation between two quadratic curves. I hope this video helped you understand the basics of.
Right. So easy, right? But easy, not simple. Coming and coming again, right? One by one. Again and again. So only 4 points is given by design. And here the t is the parameter. Only t is changing. The result, the coming out is curve is as a result. That is a basic idea, same to the other nerves. Nerves is more complicated, Bezier is a little bit complicated, but basic idea is the same. So Bezier is very nice person to
develop such one. Okay, so that this one, and then we go on to basis or B spline or basis spline. So basis function. Let me show you this one again. Right here again.
We call this is a blending.
Blending is interpolation.
So now this is a final equation for the curve. This is curve, and the parameter is t, right? And then they are somehow in some terms of cubic, but they are blending those control points. Four control points, P0, P1, and P2, and P3, right? Combining, blending them together to generate a curve. And only T is changing. T is changing from 0 to 1. Yeah. So that is very interesting, and that is good for computer. Computer is very nice to generate such iteration and calculation. Very nice. All right. So basis function very similar to Bezier, but a little bit different. But again, simply the B is a control point, and we have some kind of parameter or constant at the beginning, and then X is a parameter that is changing, right? So the curve, spline curve, the B spline curve is made of a parameter T, but this one is a blending of control points. Same idea. But in mathematical form, it looks complicated. The same idea, same basis, and same. And the parameter is coming from 0 to 1, right? And then B is a little bit complicated. But this one is again coming from the Bezier. Blending and blending and blending and blending. Right? Or complete linear approximations. But again, this curve does not pass through the control point. Bezier, you remember that Bezier, it starts from control point, ending to the control point. In the middle, it does not pass through the control point. But B spline, no touch. Control point and curve is they are influencing each other, but does not touch each other. So for function formation, equation is a little bit different. A small change doesn't. That is another function. Now, nerve is coming. Okay. So this one is a main equation system that are used inside the current software systems in the market. So you need to know about this. What is the advantage?
In this lesson, we will learn about NURBS, objects, and modeling. NURBS stands for Non-Uniform Rational B-Splines. NURBS are useful for very smooth objects or when you need an exact surface. A NURBS object always has four sides and is made of mathematically created curves which are defined by control points. An individual control point does not show where that surface will be, but it is averaged with the surrounding points to create a curved surface. This means we cannot directly edit the surface. If we pull a control point, the surface will only move a little bit because we are averaging the change. To create complex objects using NURBS, we have to create many individual NURBS objects, often called patches. A common issue when working with NURBS is visible seams or breaks in the otherwise smooth surface between patches. But with care and correct workflows, we are able to hide the seams between patches so that this multi-patch object looks like a single surface. These difficulties mean that NURBS are rarely used in the computer graphics world, but it is often used in engineering and product design because of the very precise nature of NURBS. If you need to create a very smooth object or mathematically exact surface, try using NURBS.
So ship surface also using NURBS. All right. And then so that we come to the computer system for ship design. So whole form is used by computer instead of pen and pencil. So that parametric modeling, parametric. So once again, the P we call the parametric curve. We call this parametric modeling. So only parameter is changing, then curve is generated. So when I was a student, it was very hard to generate a drawing, curve drawing, but now it's very simple. You should know that what is the inside. So it is an AP, FP. We did not explain well, but we call this as a something like a starting point, front part of the ship, and the point of the ship. After peak, for peak. It is fixed. Otherwise, ship is moving, surface, wetted surface is changing, right? So we need to, for the shipyard or designer, you need to have a fixed point on the ship. So we call this as a starting point and point of the ship. And then they divide into 20 pieces of the ship to draw this kind of curve. So that is fixed to the ship. And easy for the constructor to imagine or generate or design and production. Let's see. So generally, finally, we derive a surface. And complex modeling. So propeller should be attached here. It is a Boston. And surface curvatures can be color coded. And then surface can be modified. Right? See that? As a designer, you want to change the shape. As a designer of your car, your home, you may have a different ideas. You want to change. Shape is same. They're easy for the computer tools. Otherwise, you are trying to change your design by pen and pencil. It takes months to generate another part. But computer, it can take only 1 hour to generate a new one. So Abeba Marine is a famous computer ship design software, commercial software. From the some Sweden, Norway, Denmark, somewhere there. Katia is coming from France. Yeah. Dassault system. Dassault system. This one is very famous for automotive industry. So now, aerospace industry. But sometimes it is used for the shipbuilding too, especially for the submarine design. EGR is coming from Korea. All right. Question? No question? Then we may move on.